Maybe I can get a second opinion. What do you think, Pilot? Pilot. Hey guys, welcome back to the messy workshop and the start of a new project. So this isn't exactly the first new project I've done at the new house, but everything I've done until now has been for somebody else. In fact, the projects I've been doing for the most part for the last couple of years have been for other people. Well, I thought it was about time I worked on one of my sets for a change. So, may look familiar to you guys that have been watching me for a while. Yeah, it's another Admiral. I thought it'd be nice to break in the workshop and getting back to one of my sets with a set that I'm rather familiar with. But this one's a little bit special. I've actually worked on one of these before. What it is this guy hiding down here. It's an Admiral 24812. Now, I have restored one of these in the past, but I sold it. And I've wanted to get another one for a while now. And next to it is a very similar Admiral 20X122 I restored some time ago. Well, what's nice about this one is it's the most complete one I believe I've encountered to date. There's always something missing. Usually it's the back or some bits and pieces on the inside. Well, this one's got it all, and the cabinet is in fantastic condition. I haven't polished this up. I got it like this clean, this shiny. So that will be a nice change. I won't have to spend hours and hours and hours polishing up the bakelite. Just a little bit of cleaning, a little light polishing, and that should be that. Like this little blemish will come right out. Yep. Alright, so we'll talk about the cabinet later. Right now I want to take a better look at the chassis, which I really haven't done. I've actually had this set for a while. I got it from a friend of mine, and it was in the old apartment for, geez, I don't know, 3-4 years. I never did a video on it, I don't think, and I never pulled the chassis or took a closer look at them. So let's get started. So what are we looking at here? Well, Admiral generally stamps their chassis on the back, and this is no exception. It's a 20A1. I've restored several of the earlier 30A1 chassis, which look very similar on the surface, but when you get down into it, there are a number of differences. This chassis is about a year later, number of refinements. I think this is a really, really well-designed, well-performing set. Unlike that guy, which is fine, which uses a 20X1 chassis, but that only has a single chassis. It's a simplified, streamlined design. They cut some corners. It's got a simplified power supply. It's also got a lower video bandwidth. That guy, two chassis just like the first generation 30A1. There is a lower chassis with two power transformers, filter choke, all kinds of good stuff. We'll take a look at that later. This is the tuner and high voltage power supply, and obviously the picture tube up here. Right away you may have noticed something. There's a little problem here. Yeah, the base is pulled off. I don't know if it was like that when I got it, but it's like that now. I'm not sure when exactly that may have happened, but important thing is there are 5 wires here. That's all you get on these CRTs. It's just 5 leads. 1, 2, 3, 4, 5. So it is possible to very carefully straighten these out, clean up the ends, put the base back on. But I won't bother doing that until I know if this thing's any good or not. So I will carefully clip on some test leads and fire up my Suncor CR70. And if it is bad, I've got some spares. I can replace it. And it is an original. I can tell that right away. Why? Because we see a J, we see a J, and we see a J. And down here, they did a lot of revisions. This must be a 20A1 series reversion J. maybe J8 to be more specific. Power cord's been cut off. Oh well. I do have some new old stock replacements with the ears like this, so I can carefully extract this one and put a new one on over the old rivets, just like the original. Looks like all the tubes are present. I can tell right away some are replacements, but some look to be original. Like that is an Admiral branded tube right there. That's a Hytron, Sylvania, and so on. Another Admiral. Alright, so I'm going to flip this on its side and take a look underneath. Now, there should be 6 mounting screws present, but there were only 2. Pretty clear sign it has been worked on, and the serviceman did not replace all the screws. That being said, if there was any work done, they sure didn't do much. This looks very old and crusty and original. It's just what I want to see. That means nobody has monkeyed with it, screwed anything up. Well, I've worked on a number of Admiral chassis, so I'm quite familiar with them. So, for example, these 2-watt power resistors are most definitely original, as are these paper caps. Yeah, boy, I don't see anything, any signs of replacement. Cool. Sure makes me wonder why those screws are missing. But hey, I'm not going to worry too much about that. Nice to have this present too. I've seen that missing once or twice. That is a shield over the IF circuitry, the video IF circuitry. Audio's up top, I'm pretty sure, and the video's down through here. Alright, so I'm going to put that cover back on and flip this down and see about that picture too. Okay, I got my trusty Suncor CR70 hooked up. I sanded the leads very carefully to expose some clean metal to make good contact. Let's give it a try. Turn the filament up to 6.3 volts. And yes, we have filament glow. Excellent. Now, this being the original CRT, I expect it to be at least a little worn out, assuming the set was used at all. These things don't last forever, so if it saw some regular use, I would expect it to not test all that great. No shorts. No shorts. Now I'm testing the cutoff. When I rotate this, that needle should be moving. It's really not. Kind of erratically jumping around. One trick I've learned is you can drop the bias range down. Yeah, it's out of its normal operating range, but at least I can see if the grid is open. Still not much action. I'll go all the way down to -20, the lowest range. Now I've got some cutoff control. Alright, so not great by any means, but things got some life. I'm going to put this back in the proper range and then finally test the emissions, which are not very good. But again, at least they vary with the cutoff control. Meaning if I put this in a set, you could modulate the brightness of the screen, and even in the bad, it would still produce an image. Wouldn't be a very super bright, crisp image, but an image nonetheless. Now, that thing hasn't been running decades, I imagine, so I'm going to let it sit here for a while. Let things heat up, and maybe some contamination will burn off the cathode surface and things will improve. Unfortunately, after about 20 minutes, the emissions haven't improved all that much, and the life test is pretty lousy. That needle should not be moving right now. But it's good enough. It'll produce some sort of image, so I'm going to move on, and I will reattach that base. But I think next up, I'm just going to dive into doing some recapping. Maybe I can get a second opinion. What do you think, pilot? Is that picture tube going to be any good? So, where to start? Well, I generally like to start on the horizontal output area. It's one of the more critical circuits in the set, and often they got a lot of issues, and this set is no exception. First thing I did was check out a 100 ohm resistor. And this guy right here, the horizontal output tube, is going to the screen, I do believe. Well, it sure didn't look too good in the set. I could hardly even make out the bands on it, and check it out. Measuring 2.8K, that should be 100 ohms, so that is definitely fried. It's an 82 ohm, it's in the cathode circuit of the horizontal output tube. It measures about 100, not terribly out of spec, but it's drifted a little high, which I expect will be typical of all of these old carbon composition resistors. So, to this area, so replace a couple big power resistors down in here, and there's a few paper caps, and it's tempting to I'll give it a trial to pull out the lower chassis, but I know it gets boring for you guys if I just shotgun recap the whole thing and then turn it on and go from there. So I'll try to do this in stages. So definitely want to do that area. We'll replace this guy, and I'll check out the lower chassis and see how the power supply looks. And when I feel that I've addressed some of the showstoppers, like this fried resistor, I'll try doing a little power up. I finished doing some work down in that horizontal circuitry area, including replacing that bad 100 ohm resistor. Now I thought I'd take a break and test some of the caps I pulled out. No matter how many projects I do like this, I always seem to get some criticism about replacing the caps. The thought being that there might still be some life left in them. Well, I've also tested plenty of these, and they're always bad, but just to satisfy the critics, let's test some. So, this should be a 0.1 microfarad cap rated for 600 volts. So, let's test it for leakage. Alright, good for 100. Oh, starting to get a flash at only 200 volts. Should be good for 600. 300, even leakier. That flash of light indicates that it is leaky. The more it flashes, the leakier it is. By the time we get to 500, it is very leaky. So, definitely, that guy is bad. Alright, let's try another one. Alright, here's a Sprague cap made in USA. Should also be good for 600 volts. Let's see what we get. Starting to leak at 400 and very leaky at 500. Now these caps are used in some pretty critical circuits that see a lot of power going through them, so you don't want to go with bad cap. Alright, let's see about this guy. It's a Sprague cap made in the USA. Should also be good for 600 volts. Let's just see about that. 100. 200, 300. Oop, starting to get a flash. And at 500, very leaky. Now, depending on where these caps were being used, that might be okay. But these are used in the horizontal output circuitry, which is a pretty critical area of the set that sees a lot of power and don't want to burn up a flyback or blow out the horizontal output tube. So yes, I replaced those caps. Now, something else I want to check out is the electrolytics, which is the next big thing. So the two biggest sources of problems in all vintage TVs and radios, especially when you're talking about the 30s and 40s, basically anything pre, say, 1970, is the paper caps and the electrolytics. So we tested some paper caps, they're bad. What about the electrolytics? Well, we got one down in here, multi-section can, and there's another one here, and the rest are on the lower chassis. So yes, there is a chance they could be reformed. They may have some life left. Realistically, though, they're very, very old. These caps go bad even just sitting on the shelf. There are chemicals in them. They are as a wet electrolyte, not a liquid, but they're damp. And they dry out, the chemicals start breaking down, they start failing. Either, well, if you're lucky, they just go open. If you're not lucky, they short and can take out some other components. Well, yeah, sometimes you can reform them a little bit, or even if they're leaky, they're not leaky enough that the set won't operate. So let's give it a try. So I will try this guy down here, so it's very easy to get at. We got 3 sections here, so I'll disconnect a couple of them and hook them up and see indeed if they are leaky, and if they are, if I apply voltage for a while, if that leakage decreases to the point where the set could operate with that cap in place. And one other thing, that power resistor that was up in here, I took it out, and it actually does have continuity. It measures about 4,000 ohms. However, with all the schematics, I can pull up, say, 3,000. The original part number is kind of hard to read, but I do have the original Admiral service info. Actually, that's what this is, and this Wallace Tellier. This is a reprint of the original Admiral service info, and it says 3,000. So I'm gonna pop this guy in. A little overkill with the wattage rating of 25 watts, but it's only 3,000 ohm wire wound resistor I've got on hand. So plop that guy in place. Okay, I've got my tester on this cap, which should be I've got my tester on this cap, which should be 20 microfarad, good for 450 volts. I disconnected it from the circuit, so it's totally isolated. And let's see what we get. Change the function from paper mica to electrolytic. And let's check for leakage. Well, it's actually a good sign. So when that light lights up, it means there's leakage. When it fades out, that means the cap is charging up and it's holding a charge. So I got it up to 200 volts and it's not leaking anymore, or at least not enough for this tester to detect leakage. 300, we got some significant leakage, but I'll let it sit here for a while, see if that fades out. And the idea is, if I slowly do this over the course of 5, 10, 15, 20 minutes, I can work my way up to 400. This doesn't do in increments, so I can't do 450, but I can do 400. And if I get 20 microfarads, well, yeah, there's a pretty good chance that this will work well enough for me to power up the set. Yeah, just winked out. Something else I can do while it's reforming is check out the voltage. So I just put my DC voltmeter in parallel with the jacks on my capacitance bridge, and we can see the voltage, and notice it's slowly climbing. That's a good sign. That means the cap is forming up. It can withstand more of a voltage across it. As you can see, it's a slow process, but as long as that voltage keeps increasing, that's a good sign. While we wait, I pulled the cabinet out and turned it around. So, you can see again how nice and shiny that cabinet is. And also, here is the lower chassis and speaker. Gotta remove some bolts and pull this out. There's a big power transformer, and there's the two rectifiers and filter chokes and filter caps, audio output tube and output transformer and speaker. The chassis is held in place by 4 screws, and it's also shock mounted. Those washers down there are rubber, but they appear to be a bit compromised, shrunken and hardened, no doubt. And something else I noticed is that these speakers are hardwired in, and often when these sets have been serviced, what they do is they cut the wires, and you'll see they're taped back on, but not in this set. Also notice that this is the original rectifier tube. It's Admiral branded. And let's see about this big Coke bottle guy. Should be 5E4. Oh, it's a Sylvania. However, the CRT is also Sylvania, as are some of these other tubes, like the audio preamp tube. So I'm not sure if all the original tubes were Admiral branded. Some of them might have been Sylvania branded too. Actually, I guess that is the output tube. That's the preamp 6SQ7. So what is this guy? That's a metal 6V6. Huh. Used to sing glass types. Interesting. Also a Sylvania. Might be the original. I don't know. But what's annoying is that let's leave that out. What's annoying though is I can't easily pull this chassis out because, like I said, that's hardwired in. There's no connector on the chassis. There's just a hole in the chassis up front, and those wires lead down into it. So either I got to cut the wires, desolder them, or take the speaker out too. Back to the electrolytic. We're all the way up to 413 volts now. Still, the light is on, but it's faded quite a bit. So indeed, this cap may form up all right. Usually if one section forms up, the others will form up all right. There's 3 sections in this, another 20 microfarad at 450 volts, and then a 50 microfarad at only 50 volts. I got all the screws out, but there's one little problem. The chassis is still not budging. I think what's happened is these rubber washers have really fused the metal down to the bakelite, so I gotta pop them loose, and I'm gonna use this big old screwdriver, but you want to be really careful because you don't want to crack this bakelite. Alright, that one's loose. Let's try this side. Alright, that's that one. Still no. It's gonna be a little bit harder to get this up front. It's definitely loose now, though. There we go. So now I gotta deal with that speaker. I'm going to try to get the speaker out because I kind of want to have a speaker when I test the set too. And although I could use a test speaker, might as well test this one so I can find out if the speaker is good while I'm at it. By test speaker, I mean just another handy speaker I have on the workbench. Alright, I finally got the whole lower chassis and speaker out. The speaker was also very stubborn, which is another good indicator that this has never been serviced. And the cone is in really fine condition. Take a look underneath in a moment, but before that, let's take a look at this cap, which is still hooked up, and the light is out, indicating it has very low leakage now. We're up to 427 volts, so I don't have any issues with powering the setup for that section of that cap. Now there's two other sections on that one. Then there's another electrolytic multi-section cap up in here. We got these two guys. This is the main power supply filter cap for like the main B+, and this is the lower B+, but this sees the brunt of the power, so that's why we got the 5U4 rectifier here feeding that guy, and filter choke, I think this guy, and that's the output transformer. And then there's a 6X5 rectifier here, and that cap, I think that's a filter choke for it, so it does less power, so hence a smaller filter choke and cap. Alright, now let's take a look underneath the power supply audio amp chassis. The first thing I did was disconnect the speaker, put it away for safekeeping. Don't want to poke a hole through it. Here's a connector that goes to the upper chassis. I'm expecting this is going to be pristine, original underneath. Yep, sure is. Oh, there's also not a whole lot down here. Just some bias resistors, a cathode resistor, that's the big 270 ohm there for the 6V6 output tube, and a few caps. Alright, so as I said, that was the main filter cap, so I want to check that guy, see if it could be formed up. If not, I will install new caps. And I also notice there's plenty of room underneath this chassis, even some unused tie points on this terminal strip down here, so I will be mounting the new caps below the chassis rather than restuff the caps. I'll just leave the old caps installed and cut the wires to them. But first, let's see if they can be formed up. If so, I will try powering this setup with the chassis as is. Well, it turns out both sections of this main filter cap are reforming well, so what about the other filter cap for the 6X5 rectifier? Well, got the tester on that right now. That is the 30 microfarad cap right there. So let's give it a try. It is actually doing as well as the other caps. Now, I'll tell you what, I'm going to keep forming these up, but the way things are going, I am kind of itching to plug this guy into that guy, hook the speaker back up, and power it up. Now, I still haven't repaired the CRT, but I should be able to power this up and get some sound and some reception, even if the CRT isn't going to light up. Alright, a little foolhardy perhaps, but hey, I want to keep you guys entertained, so I have reattached the speaker. The cap seemed to reform alright. I pulled off the danger high voltage cover so I could hook up a cheater cord and get some power going to the set. Horizontal output tube and high voltage rectifier are in place. The flyback looks alright. So if all goes well, there will actually be high voltage produced going to the CRT, but because there's no filament or grid voltages going to the CRT, It's not going to light up the screen, but we could hear some crackle out of the speaker if I remember to hook this up. This is the audio output of the top chassis. It goes to the lower chassis and plugs in over here. So even though it's very early, they did actually have RCA connectors way back when. Although I kind of wonder who coined that term. I mean, this is an Admiral set. I don't know if RCA invented that type of terminal or not. And hey, I just noticed this. There's an Admiral service sticker on the back. Dickens 2 6200. It's the old way of saying a phone number. Cool. Alright, and here is my replacement resistor for the focus control. Didn't quite fit in there, so I just temporarily jumped in a little wire here. I reconnected the cap down here that I had been testing to see if I could reform it. Okay, so I'm going to turn the set on here and then use this for the power control. So here we go. I've got this to measure current, so it spiked over and then it dropped down. Tube should be lighting up. I want to kill the overhead lights a little bit. Yep. Well, and we do have static coming out of the speaker. The current is holding pretty steady. I'm on the 1.5 amp range. We're like 1.2 amps, which is fine. Static doesn't seem to vary a whole lot with the volume control, though. I don't have any knobs on this set, so I can't change the channels right now. If the set is working at all when I go to channel 6, which is still broadcasting, I should be able to hear something. Okay, I borrowed some knobs from another set, so I can change the channel now. I think that should be 6. Volume's all the way. I noticed the volume is not changing with the volume control, though. Which is not a good sign. Just wiggling the tubes here to make sure they're all seated properly. This is the sound IF right here, so that's good that I'm hearing a crackle as I move these tubes around. I don't have any antenna hooked up, so let me clip something on here. Nah, I'm still just not getting anything. And I notice that things don't change as I change the channel. So yeah, I really didn't think it was going to be quite so simple. I can do a few tests. One is this warm? Barely. Which means this set isn't drawing a whole lot of power. That guy's down near cold. So it could be these caps haven't quite formed up enough and the set isn't getting full power. Oh, well, these are kind of cool. Let's check the output voltage here. That's kind of low. I'm going to turn my variac. It's only at about like 105. Get up to 117. Yeah, getting some more life now. That's more like it. So there's channel 6 right there, and see how dirty those contacts are? I'm going to try cleaning those up with a Q-tip and some deoxit. Okay, I swabbed the channel 6 section with some deoxit D5. This is meant to be used on switch contacts. For potentiometers, you want to use something like deoxit fader F5. Alright, well, let's see if that did any good. Ooh, I hear something. It's faint, but it's there. Huh, how cool is that? Well, that is very promising. Turn it down before I get flagged for a copyright violation. Oh, I so wish I could fire up the CRT right now and see if I get an image, but I gotta repair that base first. Alright, well, this should be a lot of fun, because with just a minimal amount of effort, I have got it to power up without blowing up and receive a signal. So it should be all downhill from here. As I replace each component, things should get better and better. Now there is one last thing I can do before I repair the... Well, there is one last thing I can do without repairing the CRT base, and that's see if there's any high voltage going to the anode. Now, I haven't located my 40,000 volt probe since I moved, but I got my 6,000 volt probe. Again, don't try this at home. If this is producing the voltage it should be, this probe is really not sufficient to handle it. 6,000 volt max. If this is operating right, it should be more like 9,000, but I kind of know what I'm doing, so I'm not too concerned. So the deal is high voltage is coming from the base of the high voltage rectifier in here, if everything's working, going up through this wire, which is insulated, rated for high voltage, and connecting to Now there is one last thing I can do before I repair that CRT base, and that's see if there's any high voltage. Unfortunately, since I moved, I don't know where my 40,000 volt probe is, but I do have this guy, which is only rated for 6,000 volts. So I do not recommend you try this at home, but I think I will be alright. So I've got this plugged into my Fluke, and the deal is, if everything's working right, there is high voltage to be generated by the flyback down here, and here's a rectifier tube, and this wire coming up here has high voltage on it going to the anode of the CRT. To test it, get the probe underneath that rubber cup there. I'll pry it up a little bit, and even just hearing that, forget about what the meter may say, but just hearing that squeal means there's high voltage present. That's awesome. See if I actually get a reading. Cool, almost 9,000 volts. Again, exceeding the rating of this probe, but it held up. Fluke makes good stuff. We've got high voltage. That's great. It means the horizontal circuit is working. And I bet I could get a raster if I can reconnect all those wires, so that is definitely the next step.